Alright guys, so these two problems are very stereotypical problems that we ended up finishing yesterday. And the directions are the same. Our job is to simplify these two problems, aka make them look simpler. Now when I see number one, the first thing that I want to see here, or I want you to see, is that all these bases are just multiplying each other. And each of those bases have their own exponents. Notice that this 3 has an exponent of 1, this x has an exponent of 1, and this y also has an exponent of 1. Now, why does it have an exponent of 1? Because there's none there. If there's none there, it's kind of implied that there's a 1. Now, first thing I see here is that, okay, I am multiplying. I have a constant, a number 3. Can I multiply a constant by any of these variables? No, so I'm just going to bring it down. Now, I'm going to move on to my next variable, see if I can simplify that with any other variable. Now, remember that when you're multiplying bases, in order to add their exponents, you have to have like bases. For instance, what I'm trying to get at is if I have an x raised to the negative 2, you only can combine it with that other x because they have to be like bases. Your base stays the same, and then you want to add the exponents. Negative 2 plus 1 is a negative 1. And then you just want to repeat the process over and over again for all the variables until you've combined every variable that's been combined with every variable that it could be combined with. So notice that I have a y to the negative 3 and a y to the 1. So my base stays the same. Negative 3 plus 1 is a negative 2. Now, notice that I didn't let the negative numbers freak me out there. All I did was just kind of take my time and apply the product property. For someone.
This kid was here second grade.
No, he wasn't.
Thank you so much.
So after you're done doing that, you can see that we have some negative exponents, and it's improper to write negative exponents, so let's get rid of them. Now, the main thing that I want to get here is to understand that this is 3 times x to the negative 1. This 3 has its own exponent, so as I look at this x, it has a negative exponent that needs to be dealt with, and so does this y. So let's go ahead and do that. What I like to do is always write my fraction, leave whatever doesn't need to be taken care of by itself, and move everything that does. So this 3 has a positive exponent, so it doesn't have to go anywhere. This x has a negative exponent, so I'm going to move it to the opposite side. The action of moving it to the opposite side of the fraction makes that exponent a positive. And notice that this y also has a negative, so it also gets moved down. The action of moving it makes that exponent a positive. So notice that you end up with x times y to the 2 in the denominator. Now notice that once I move that x, there was no exponent because it becomes a positive 1. Is it really necessary to write a positive 1? No. So that's that one. Let's go ahead and try number 2. Now the first thing I notice here is that there is a fraction, aka a division. So whenever I'm doing division, I always like to start with the constants. What is negative 4 divided by negative 4? What's anything divided by itself? 1. So the easiest thing you can do is really cross those out because you know that that equals a 1. 1 times anything is itself, so you're left with whatever's left over in the back. So let's go ahead and solve one of these step by step. Now remember that when you are multiplying like bases, you add their exponents. So we don't really mind when there's negative exponents. We're just going to apply the rule because it's a little easier to add negative numbers. But notice that when we divide like bases, we're subtracting. When we subtract negatives, things get a little confusing. So always get rid of the negatives. Deal with them first and then do the math at the very end. What I mean by the math is the properties of exponents. So let's look at this first a. Does it have a negative exponent? Yes. So I'm going to move that a to the bottom. Here's my a. The action of moving it to the bottom makes that exponent a positive. That b to the 3 is okay because it just has a positive exponent. Notice that this a to the 5th is going to stay at the bottom because, again, it has a positive exponent. And same thing with that b to the 4. Now it is time to apply the properties. I can see here that I have a b in the numerator and a b in the denominator. You're dividing them. When you divide two like bases, you subtract their exponents. But where are there more b's, in the numerator or the denominator? The denominator, so your b is going to go in the bottom. 4 minus 3 is a 1. I'm not going to write the 1 because it's really unnecessary. Notice you have an a to the 2 times an a to the 5th. What are these two bases doing to each other? They're multiplying, but you would add the exponents, right? So your a stays the same, your base, you add the exponents, 2 plus 5 is 7. Don't forget that this is all going along in the denominator, so you still need that 1 up there in the numerator. So that is what we covered yesterday. The biggest thing that I want to highlight again is that if you're multiplying, go ahead and do the product property, add their exponents. But when you're dividing, aka the quotient, make sure you deal with the negatives before, so that way there's a little less confusion. All right, so let's add one more property, which is the power property. And the power property really is just when you have an exponent raised to another exponent. Now, anybody have a guess of what we're going to do to simplify this? What happens to the base? What happens to the exponents? Do we add, subtract, divide, multiply? What do we do with them? Well, if we expand this out, it's a little bit easier to see what goes on when simplifying this whole string of numbers. And let's start with the basics. Notice that I have a base of 2. It is getting raised to the 3. That means I'm multiplying 2 3 times. Now this is also getting raised to the 2. So that means I'm multiplying 2 to the 3 another 2 times. So let's go ahead and expand this. Again, I'm multiplying 2 to the 3 2 times because that is what that exponent is telling me to do. Now you can see I have 2 raised to the 3 that's multiplying itself 3 times. Another 3 times there. So how many times am I multiplying my base? 6. I am multiplying the number 2 6 times. So what do you guys think? What can we deduce from this little expansion here? If I have a base that's getting raised to an exponent that's getting raised to another exponent, does my base change at all? No. What do I do to the 2 exponents? You multiply them. Absolutely right. Of course, if you're kind of struggling, I would say to expand it, but you don't want to waste too much time because these are really just look and see problems. You got to be able to apply the rules just like that. All right, so this is just another example to kind of send it home. Notice you have an a raised to the 2 raised to the 4. Remember that this is just a base of a getting raised to the 2nd power getting raised to the 4th power. Your base stays the same, and then you multiply the exponent, so you end up with a to the 8. If you were to expand that, you would have a to the 2 multiplying itself 4 times, and then since you have those 4 times, you multiply it 2 more times, and it'd be a little bit more messy. But again, this is, more of the story is multiply the exponents. All right, so just to make sure that you guys got this down, I want to practice just very basic power property of exponents. So the first 3 are very basic. Number 6, 7, or 8 are also basic, but there's little things that students always miss. And my goal is to highlight them in 6 and 7 and 8 so that way you don't do them on a test or when you do your practice and stuff. So let's start with these. If you need help or clarification, I could also help you on any of these, really. All right, so looking at the first 3 problems, this is just making sure that we practice the basic rule of the power property. And before we start, let's kind of remind myself, if I have a base raised to an exponent that's getting raised to another exponent, then how do I simplify? Well, my base is going to stay exactly the same, and then I'm going to multiply the exponents. So notice here that we have 5, the base of 5, getting raised to the 2nd power, getting raised to the 10th power. So my base stays the same, and then I multiply the exponents. 2 times 10 is a positive 20. And that's pretty much it. Let's go on to the next one. We have a base of 2 getting raised to the 2nd power raised to the 4th power. Your base stays the same, but you multiply the exponents. 2 times 4 is a positive 8. Now, last but not least, number 5, we have the base of x this time. So my base stays the same. Doesn't matter if it's a variable or a number. And then I'm going to multiply its exponents because it's an exponent raised to an exponent, the power property. 3 times 4 is a positive 12. And that's pretty much it for the basics, right? Now let's do a couple of tricky ones to make sure that you don't fall for the little teeny mistakes that give half a point off. So if I look at this problem here, notice that I have a base of 2x. 2x is getting raised to the 4th. So how many times am I multiplying 2x? 4 times. This literally reads out as 2x times 2x times 2x times 2x. So how many times am I multiplying 2? 1, 2, 3, 4. You're multiplying 2 to the 4 times. So that means that's 2 to the 4th. How many times are you multiplying x? 4 times as well. So what's the moral of the story that I want you to get from this example? Is that notice that you have a base of 2 that's getting raised to the first exponent. Notice that you're multiplying that by the base of x getting raised to the first exponent. So whenever you simplify, make sure that you understand that each base is getting multiplied. So that means that you have to, if it helps you, write a 1 up there. So that way you can see 2 raised to the 1 to the 4. 1 times 4 is 4. X to the 1 to the 4, 1 times 4 is also 4. So make sure you simplify this out so that way you can see it, okay? Now, this is just kind of piggybacking off number 7 on number 6. Because notice you have a base of x, which is getting raised to the 3rd power, and a base of y getting raised to the 2nd power. And that is all getting raised to the 4th power. So if you have an exponent to an exponent, what do? Multiply. Your base stays the same. 3 times 4 is a positive 12. Your base of y stays the same. 2 times 4 is a positive 8. So you notice that is all you need to simplify that one. Now, let me show you how number 8 pretty much piggybacks off 6 and 7. Now, just like we said on number 6, negative 4 is its own base. 8 is its own base. These both have an exponent of 1. So this becomes, okay, this is negative 4 raised to the 3rd power and a raised to the 3rd power, because again, 1 times 3 is 3, 1 times 3 is also 3. Now, do you guys remember that one thing I told you? Whenever you have negatives with exponents, how do you tell the reader, hey, we're multiplying everything? And it's the parentheses. You have to remember that whenever you have something that's negative, that's getting raised to a power, always include a parentheses to tell the reader, hey, man, the negative is included in this repeated multiplication. So notice now that I have some fractions, and again, nothing changes. Everything in the inside is getting raised to that power. So if you have something like 2 over 3, this is its own base, this is its own base. What is the exponent of this base? It's a 1. How about this base? Also a 1. So if you're simplifying a fraction, just make sure that everything every power gets raised to that power. 2 to the 1 to the 2, your base stays the same. 1 times 2 is 2. Notice that 3 to the 1 to the 2, your base stays the same. 1 times 2 is 2. So this is just to highlight that make sure that everything within the fraction is getting raised or getting affected by that exponent. So try number 5 and 6. We'll go over this in about like 10 seconds, I guess. 15. All right, so this is just additional examples to make sure that you guys are focusing on what I'm asking to focus on number 9. So notice that we do have a fraction that's all getting raised to the 5th, but we're not going to let that fool us because, again, these are all their separate bases, and all those bases are getting raised to this exponent on the outside as well. So how do I simplify this? Remember, exponent times an exponent, or exponent raised to an exponent, you multiply. So x to the 1 to the 5th is going to become x to the 5th because 1 times 5 is 5. Y to the 1 to the 5th is going to be y to the 5th because 1 times 5 is 5. Now, looking at the second one, notice that this one is a little more complicated, but not really, right? Because I'm doing the same thing over. This is a base of a getting raised to the 4th power, getting raised to the 5th power. This becomes a to the 20. Remember to multiply the exponents. This is b to the 1 raised to the 5th. 1 times 5 is 5. Don't forget that your b is in the denominator, so it stays in the denominator as well. Now, that is pretty much as basic as we can get in terms of understanding all the little things to watch out for the power property. Now let's put it together with product power, all those other properties that we've learned to make sure that when you have them all in one example, you know what to do. Right, Dave, you're ready for this one? So notice you end up with problems like 12, 13, and 14, right? There's so much things going. There's powers to a power. There's things getting multiplied. There's a lot of things going on. Now, how in the world are we going to pretty much figure out what to do first? My biggest suggestion is to always remember your rules or your order of operations. It is memorized with PEMDAS. It's pretty much a way to memorize the order in which to do math. You want to do the work inside the parentheses, go to exponents, multiplication, division, followed by addition and subtraction. So if you see a problem like number 12, start with the parentheses. Is there any work to be done inside of these parentheses? Can you simplify it any way, shape, or form? No. Now, is there any exponents? And what I mean by that, is there an exponent raised to another exponent? Yeah, it's this guy right over here. So concentrate on simplifying that part first. This is x to the 2 raised to the 2. What does that simplify to? 4. This is y to the 3 raised to the 2, so it's y to the 6. Now notice that these parentheses, there's nothing in the middle, so all it's really doing is just multiplying. So I'm just going to rewrite it as multiplying now. Now, is there any more exponents raised to an exponent? No. Is there any multiplication? Yes. All these are getting multiplied. Notice you have a base of x and a base of x. Remember your properties. When you multiply two like bases, what do you do to their exponents? You add them. So your base stays the same. 4 plus a 1, because remember there's no exponent, would be a positive 5. Y to the 6 times y to the 1 would be y to the 7, because again you add their exponents. So notice that although it looks really complicated, if you take one step at a time, you do one property, rewrite it, it becomes easier and easier to the point where you're like, okay, that wasn't too bad. But you got to remember to start one thing at a time. So try 13 and 14. One thing that I have to remind you guys, don't let the negative exponent fool you. Start with the work inside the parentheses. Can you do the work within? If you can't, go on to exponents. How do you deal with an exponent raised to an exponent? Then do the multiplication, and then worry about the negatives at the very end. You shouldn't be worried about them at the beginning. All right, guys, so I really like this problem. And the main reason is because you're really doing 3 different properties within one. And the one thing that I would suggest not to do is try to do all of them at once, or be picky and choosy. I'm going to do this one first and then this one second. Do the same process over and over, so that way, no matter what problem I get you, if you practice the same routines, you're going to get better at that same routine, and these problems are going to become simpler and simpler. So, for instance, when I see this problem, I know that there's no work to be done in the parentheses because there's no bases that are the same within. Then I'm going to go to exponents. Now, I do see here that I have a base raised to an exponent raised to an exponent. Now, remember that this 2 has an exponent of 1. The 2 and the x are separate, right? So make sure that if it helps, you put that little 1 there. Now, remember that when you have an exponent raised to an exponent, you multiply. Your base stays the same. 1 times a negative 2 is a negative 2. Now notice you have x to the 2 raised to the negative 2. So your base stays the same. 2 times a negative 2 is a negative 4. Y to the 5 raised to the negative 2 is going to be y to the negative 10, because, again, you want to multiply those exponents. And now, don't forget that this is multiplying times x and y. You can see that all these guys are just multiplying each other, so notice that we're at the multiplication part. Now, notice you have a base of 2. Is there any other base of 2 anywhere here? Nope. Notice you have a base of x. Is there another base of x? Yes. Now remind yourself again that that base has an exponent of 1 because it's not written. So when you multiply 2 like bases, the base stays the same. Negative 4 plus 1 is a negative 3. Y of negative 10, y raised to the negative 10 times y to the 1, base stays the same. Negative 10 plus 1 is a negative 9. Now, you'll notice here that we did the power property to begin with, and then we did the product property, and then now we have to start dealing with negative exponents, because remember, it's improper to have negative exponents. But they are all right to deal with, because all we have to do to get rid of the negative exponents is move the base to the opposite side. So this 2 is going to move to the denominator. The action of moving it makes that exponent a positive. Same thing with the x. Let's move it to the bottom. The action of moving it makes that a positive. Let's move the y. The action of moving it makes that also a positive, so you end up with positive 9. Don't forget, there's nothing in the numerator. You want to include that 1 there. Okay? All right, so is it okay to erase so I can show you how to do that 14-1? So if you look at this one again, I see a lot of things going on, but I'm just going to take one step at a time. There's no work to be done inside these parentheses, so I'm going to do the exponent to an exponent. Now, sometimes what I like to do is when I have an exponent to an exponent, just circle them, because then I can kind of analyze it a little bit better. A to the negative 2 is going to be a to the negative 16. You're going to end up with b to the negative 6, because again, 3 times that negative 2 is a negative 6. Now notice that you also have an exponent here. Now I'm not going to forget that these both exponents have an exponent of 1. So you'll end up with a to the 3, b to the 3, because 1 times 3 is 3. 1 times 3 is 3 as well. Okay. Now, what are you left with? You're multiplying all these guys. You have a base and a base. What are you going to do to its exponents? Add them, right? You have another base and another base of b. You end up with b to the -3 because -6 plus a +3 is a -3. Almost done. All you have to do is get rid of that negative exponent. So let's move it to the bottom. The action of moving it makes that exponent a positive. Let's do the same thing with the b. The action of moving it makes that a +3. Don't forget your 1 on top. Is that all right? Okay. Now, just for time's sake, I want to give you guys a little bit more time to work on your guys' stuff. I want to show you one like number 17, where you have a division. And the biggest thing that I want you guys to understand is that you're doing the same thing as before. Start with your work inside the parentheses. Is there anything to simplify within these parentheses? Not really. You can't combine any, right? So let's go ahead and go to exponents. Now remember, you have x to the 5th to the -2, y to the -2 to the 2, x to the 1 raised to the -2. So all those exponents are going to get multiplied. You're going to end up with x to the -10, y to the +4, and then z to the -2. 5 times a -2 is a -10. -2 times a -2 is a +4. 1 times a -2 is a -2. Now remember, you're doing division, so let's go ahead and deal with the negative exponents first. This x, does it have a negative exponent? Yes, so let's move it to the bottom. So which is going to get moved to the bottom. The action moving it makes it a positive. I'm going to cross it out, that way I know it's gone. Now you have y to the 4, it has a positive exponent, so that one's cool. Notice you have the z to the -2, I'm going to move that one to the top. So that way, the action of moving it makes it a positive. Forgot to change the negative, so make sure you're not like me. And that's it. If you could do these ones, you're gonna be all right.